Hi, I'm Doug Coughlin, and I'm going to show you how to make new handles actually made for a refrigerator using a CNC router. This is just somewhat special in that I'm going to do it on a 2.5 axis CNC router, and it's going to be a full 3D cut. So the finished product will look like this. This is cut on all four sides. A little bit of background about this project. About 2 years ago, I noticed this book online called Build Your Own CNC Machine, I think it is, by Patrick Hood, Daniel, and James Lloyd Kelly. On the internet, I downloaded that book and I built this router. Here it is. It's pretty close to what they had described in their book. To date, I have only been doing 2D cuts, and I wanted to try a 3D cut. So that I needed new handles for a new refrigerator. I noticed they were very expensive online to just buy them outright. I thought, well, I'll give it a try. A little bit more about this. You should know that I'm not an expert in machining it by any means. I'm basically a beginner. This is my first CNC machine I've ever really operated. So I thought this video might be helpful for other people that are trying to wade through this problem. So a little bit more background on this. The design workflow to create these handles, I used OpenSCAD to do the development. Then from OpenSCAD I exported it into STL files, which then are imported into HeeksCAD, and HeeksCAD generates the CNC code. Then with the output of the G code from HeeksCAD, I input it into OpenSCAM to simulate it. And once I had it all simulated on all four sides, then I moved it onto another computer in my garage. And am using Linux CNC to control the machine. So you might want to change this design, and the files have been made available on the BuildBotics website. In order to change the design, you would need to open up the OpenSCAD file, and you can modify it accordingly any way you want. Don't forget, when you do it from OpenSCAD, you can change the design. Then you need to press F6 so that you create a new STL file, or the ability to export it, an STL file. If you put in a lot of complexity into the design, you'll find that it will take forever to execute that. So I've limited the amount of complexity that I put into the workpiece, and still was able to get what I wanted out of it. Now once you get done in OpenSCAD, then you would need to import the four files, one file for each side, top, left, right, and bottom, into HeeksCAD one at a time, and create a new use HeeksCAD to create the CNC code. And then from there you should take those files, output them into in the G code format, and then input it into OpenSCAM to simulate it. Once OpenSCAM shows that you have exactly what you want, then that's the time to bring it down here and execute. In order to build one of these handles, you're going to need a piece of hardwood, exactly 1 7/8 inch square and 28 inches long. I found these pieces at Home Depot. They're 36 inches long, and then cut them to 28 inches. You'll also need 2 bits for your CNC router, one being a 1/4 inch in diameter, flat-ended bit, preferably with 2 flutes, and 2 1/4 inches long. And the second bit, the first one will be called Tool 1 in the tool table. The second one will actually be Tool 3. Not Tool 2, don't get that mixed up or it won't work. But Tool 3 in your tool table, and it will be 2 inches long with a 1/8 inch cutting diameter and 9/16 inch cut length. Okay, you can do a little bit of convenience preparation on the workpiece before you start by marking the sides. You'll need to know which sides you're working with as you flip it, because you need to have the correct side up for the file that it's cutting from. Remember that the CNC router can only cut vertically down. Okay, so I did that by marking a T on the top, an L on the left, an R on the right, and a B on the bottom. Okay, and you can do that. You want to make sure the left and right are situated so that as you look down the x-axis, the L is on your left and the R is on your right. Okay. Okay. There really are two things that are quite difficult about trying to do a 3D cut on a 2.5D machine, especially one that's homemade and not particularly accurate or rigid like mine. So one of the two things that's critical is registration, and by that I mean that the workpiece has to be in exactly the same place for each cut. So as you rotate it from side to side, you need to have a method that puts it in the exact spot where it was on the previous side. Otherwise your cuts will be off, and they'll either be so far off that you can't use the end product, or you'll be using sandpaper for the next 5 hours to sand out the ridges in the machine. The other piece that's very important is that the workpiece needs to be held perfectly still. If the workpiece moves, once again, your cuts will be off and it's going to be all wrong. Now, holding the workpiece in place is exceptionally difficult, because you may notice that my workpiece is exactly the same size as the finished product. In other words, I don't have any room on the outside to hold this piece of equipment down. So I've worked up some schemes, recommendations. I'd be perfectly happy to hear other ideas on how to get this thing registered perfectly and hold it still, but I'm going to show you how I did it. So the first thing I do is I make a mark on the table where I want XY to be 0. So if you look right here, you can see I got a little cross put in it, and that's where XY equals 0. Now you also notice that I got a piece of MDF on top of my table, because I don't really want to have to put marks on the work surface on my CNC machine, and if a cut got a little bit lower out of control, I don't want to scratch the surface of my table. So you might think about doing that. Okay, so once you have the mark placed, you set the XY equals 0 corner, which is the very corner of the workpiece, right on that spot. Okay. Now the next thing I'll do is I'm going to take the machine. I'm going to move it to the point where I have the XY 0 marked, and I'm going to home the X and Y axis at XY equals 0. Okay, I've already homed the X and Y axis, and now I'm homing the Z axis. The way I do that is I just move it down very slowly until the paper stops moving, so it's clamped down on the paper. You want to have Z equals 0 at the very top, exactly at the top of your material, which is exactly what we're doing. Okay, it's going a little slow, so close. Okay, that's it. Stop. Raise it up just a tad. A little more. A little more.
Oh,
okay, that's good. Okay, once the X, Y, and Z axes are home, just move the workpiece out of the way, and then move your machine down to the far end, near the far end, not exactly at the far end. I'll take it down to X equals 25 inches, and the important part is we're going to go to Y equals minus 0.125 inches, which is exactly 1/2 the width of the bit. Okay, now we're going to drop the Z-axis down to where it overlaps with the wood. So I'm going to set it at Z equals minus 0.75. And then I'm going to take the workpiece, I'm going to take the XY corner and put it exactly at 0. I'm going to put the wood right up against the bit. So remember, it's 1/2 bit width from 0, so that should put the machine square. Once that's done, we just take a pencil and draw a line all the way around the workpiece, and that's inside that line is exactly where we'll set it for each cut, or each time we want to re-register the workpiece. Okay, as I said, it's critical that the workpiece stay exactly in the position you put it. If it moves during the cut, then it's going to mess up the cut, obviously. And there's nothing to hang on to, so I'm doing two things to resolve that. One is I'm using some big clamps to hold it down in place, and the other is I'm taking these small finish nails and I put 6 of them, 2 on each side and 1 at each end, at the edge of the equipment so that it can't slide laterally at all. Okay, you'll notice that I now have the workpiece secured to the wood. I have a vice grip type clamp on this side. Notice I put an extra piece of wood between the clamp and my wood because these will put dents in your wood. That's sort of a homemade clamp set up here. The clamps are positioned in such a way so as the machine will not collide with the clamps as it moves around. So we're going to cut the bottom first. The reason we're cutting the bottom first is because once the top is cut, you no longer have a flat surface to lay this on, so the top will be cut last. So the sides, each side keeps a flat surface, and finally you set it up like that and cut this in. But if you'll notice on the bottom, if you lay it in here, our end result, we're going to have the cutting is basically from here to here, and there won't be any conflicts between the machine and the clamps. And you're going to have to possibly adjust the clamps each time you rotate the material for a new side, and then when you cut the top, there is no place you can put the clamps because basically it cuts along the entire surface of the top, and it finally you'll have to actually move these clamps around a little bit, and at some points you probably even want to hold it down with your hand because it'll take a few hours to cut this out, and you don't want to get clear down to the end and have an error a cutting error and destroy your workpiece. Okay, so we're ready to start it, and here we go. Let's see. I have the bottom loaded. It's called handle_bottom.ngc. Well, okay, it tells me to put in the tool number 1. Remember, that's the 2 1/4 inch bit. I already have it in there. I took my measurement on it. I turn on my router. Okay, the bottom cut is completed. I would say it took about an hour to cut that out. So now we're going to flip it over to the left side up. We still have our nails in the wood, and we have our marks that we put down on the table, so we know exactly where to put it. If you look at this thing, it looks a little hokey. It's got some big bumps along each side. This isn't cut out yet. Don't worry, because when we cut the sides, it'll get those. So I'm going to put the L up. Make sure there's no debris on the table, because that'll mess up your height. And put it right back in the spot where it was. Okay, there it is. And then we clamp it back down. Here. And we'll restart it and continue. I'll move on in. You won't hear me when I start moving to the right side. When I do it to the top, I'll stop and explain a couple things about the top. Okay, the bottom and the sides are now cut, and it's time to cut the top. Now the top's tricky because the entire surface of the piece gets cut, and you can see that's a problem because I have my restraints on either end. So as the As the bit approaches either end, you're going to have to remove the restraint from that end. Problem with that is there's a lot of stress on the material when it's cutting, especially when it's doing its rough cuts, and it tends to throw the piece out of alignment. In fact, I had one instance where it actually picked the piece up off the table and nearly ruined it. So the nails, these little nails, aren't really enough to hold it in place. Okay, so you're either going to have to restrain it somewhere behind the cut, or simply hold it down with your hand, which is what I've been doing. Keep in mind, it's a machine tool, and if you get your hand near that bit, you're risking an injury, so don't do that. Anyway, we're ready to start the top cut. It took about an hour total to cut the two sides, maybe about 45 minutes to cut the bottom. So we're into this for 2 hours and, well, an hour and 45 minutes, maybe almost 2 hours. It'd be a disaster at this point to ruin our work piece, because then we're starting over from scratch. So you got to be attentive throughout this entire cut. You got to be ready to remove the restraints. The way to do that is to jump on your machine. Hopefully it has a pause, and you can pause it as it's heading for one end to the other, and then adjust your restraints. Make sure you're still aligned with the marks on the table, and then resume your cut. Okay. Let's see. Oh, the good news is we can leave the restraints on for now, because the first cut is in this middle area, so it doesn't get to those restraints. So it's going to do a rough cut in the middle, and then it's going to head for the ends. When it starts heading for the ends, pause it and remove the restraint on that end. Okay. Okay, we're about halfway through the top cut right now, and the machine asks us to change tools. So I've done that. I took out the tool number 1, put in tool number 3. Remember, tool number 3 is the 1/8 inch bit that's 2 inches long. The place you can get screwed up here is if you don't push the tool in all the way into the chuck, because the software compensates for the length of the tool, and if it's not pushed all the way into the chuck, you'll have the wrong length and you'll cut the material and mess it up. At this point, the machine should be sitting near the x=0 end, and the restraint on the X end should be off. You should leave that off, because it should start cutting right at that end as soon as we restart the machine, and then it'll cut down here and then start heading this direction. So then you once again, feel free to pause the machine halfway. Well, you're going to need to pause the machine halfway down and move your restraints back to this end. Now, when you put the restraint back on this end, keep in mind that this is the final cut, so you got to make sure you don't put any dents in your final cut, because then you'll have more sanding to do. Okay, so we're going to proceed. Okay, one more thing. You'll notice that I pulled the nail out, this restraining nail out on the end down here, because the bit's going to get dangerously close to that, and you don't want the machine to get tangled up with that bit and flip it out at you. Just a reminder, you should always be wearing safety glasses when you're doing this, because it certainly is possible for bits and pieces to fly off the machine and hurt you. Okay, so the cut's all done, and if you look closely you can see there's some flaws in it right here, and right here. These are caused by registration errors. And then over here there's that's pretty rough. This is a registration error in here, and in this spot right here the piece got loose. It was in the final cut. However, these aren't very deep, and when the piece got loose I was able to catch it very quickly, so I'm pretty sure I can sand these out. We'll have a real nice piece when we're done. I'll finish up the video after I'm done with the sanding. Okay, I was able to sand out all the errors, and we have basically the finished cut. The only thing left to do now is stain it if I want, and varnish it, put it on the refrigerator. And I'd like to thank my video producer, Molly Coughlin. Could you put the camera on yourself for a second? Okay, thank you. And that's it for now. Thank you.